So let's get it started, I guess. I'm Mark Sandman, and I'm the plumbing and water heating sales manager for the Granite Group. And we welcome this opportunity to present some state products. We're going to talk specifically about the state hybrid water heater, and we've talked about this with the New England Appliance group for a while now, so we have the opportunity to do this. We are being recorded, so if anyone's after you, scrammo, and but we will have you'll have the opportunity to share this with people later. I'm happy to be joined by Jason Smith of Urel. He just waved his hand, and Chris Gould sitting on the beach, who's also with Urel, who's going to be doing the bulk of the presentation. He's he's Urel's technical guru, so if there's ever a problem, there you go. But without further ado, we'll have an opportunity to do question and answers. You have the chat function on your computer screen. You all will be muted for the presentation, but with the ability to mute yourself. So without further ado, Chris?
All right. Thank you, Mark. I thank you for having me today. We're going to talk about residential heat pumps as our primary focus today. We're just about 10 years into this product line being in this market. It's certainly not new technology. We had heat pump technology for water heaters all the way back to the 70s. Just really as of recent, in the last 10 years, though, we're packaging them all into one water heater with a compressor on top of a water heater. It's evolving. We're constantly updating and changing, and certainly in the future this will be evolving quite a bit more. But today we're going to focus on three primary units, 50, 66, and 80s. And we're going to go over kind of just the basics of it, the importance of sizing, some little tidbit on rebates in the Northeast that are always changing also. Really the idea behind this is that the involvement is net zero and reducing your carbon footprint, which has become a big focus here in the Northeast for our utility companies. So without further ado, I'll jump right in here. We call it the State Premier line. Our heat pump family makes up of three separate sizes, 50 gallon, 66, and 80. We have an HP-X, the X standing for 10-year warranties, and we have an HP-6, which is a 6-year warranty. They both have efficiencies, uniform energy factor efficiencies of 3.45 in all model sizes. We can run on dual voltages. This is a common question, 208 or 240, no problem. It'll just slightly derate on 208. And they're all Energy Star qualified and AHRI listed, which is important for the rebate side of things, which is really driving this product line. We say the word hybrid. The reason for hybrid is really we have two heat sources with heat pump water heaters. We have our heat pump on top of the water heater, and then we have standard 4,500 watt elements that are installed in the unit, two upper and lower, and they're really meant to be a backup. So the nice thing that I like to preach about heat pump water heaters is really the fact that we have two heat sources means that we have redundancy in a way that if we have power, we can make hot water off of either the heat pump alone, the elements alone, or what we call as hybrid, which would be both. Both can actually operate at the same time. In general, heat pumps are about 3 times more efficient than a standard electric water heater. The heat pumps use about 73% less electricity here in the Northeast when we're recovering primarily on the heat pump. But what we want to do here in the Northeast is run them in hybrid mode. We have 3 modes. You can run it on efficiency mode, which would be heat pump only. Hybrid mode, which would be it chooses based on duress of the heat pump as the primary and elements as backup. That's what we keep that in, is hybrid mode in the Northeast, or element or electric mode, which would be the elements only. Kind of just some basics behind this. I'm sure people are familiar, but a lot are not. Each brand does it a little bit differently, but for us, our heat pump water heater, the manner in which it will work is we'll bring in air through the top. So our filter's on the top, we're pulling air in through, we're passing it over an evaporator coil where we're absorbing the ambient heat in the air, passing it through, compressing it into the compressor, and we're producing heat through little refrigerant lines that are wrapped around the outside of the steel tank. That transfers to the water. In that essence, we get hot water from it. We use styrofoam, a non-CFC foam that actually is surrounded by the coil, so that insulates the heat only inward to the tank. Our HPX, which is the kind of the primary item that we sell here in the Northeast, the 10-year warranty tank. Again, it runs 208, 240. A common question that we'll get is how many decibels, how loud is it per se? It's 51 decibels on average, 3 feet away from the unit, which is equivalent to about a window air conditioner, noise-wise. You'll notice down below our UEF is now our efficiency rating that we use with Energy Star. UEF is based on bulk storage capacity, and they are all rated at a 3.45, which are our lowest or our highest threshold here in the Northeast for rebates would be 3.0. And we do have other states that ask that they're higher than 2.6. We certainly meet that efficiency rating without any issue. Some things that we try to do, and we can help calculate, is based on kilowatts, we can give you an annual operating cost, an average annual operating cost. We can help if you ever have a customer that's asking, to try to drill in on how much they're really going to save. We would size that by person and usage, and we can give you an annual cost savings. All of them are meant to be really a replacement water heater in the form of how they're wired. So heat pump water heaters in this market are really driven by the replacement market. They're all rated to be run with 30 amp double pole breakers. So anyone that has an electric water heater already in place, they have the wiring system set up to immediately accommodate a heat pump water heater. There's no wiring or breakers that will need to be changed. Really, the basis of design for heat pumps is replacing standard electric water heaters, and we wanted it to be a slide-in product for that reason. We use the same wiring primarily in replacement. 6 years, the same thing. Really, we're just talking about a slight efficiency change in the product line. They're very slightly lower, but the warranty is one of the primary differences between the two. If we're in a competitive situation, let's say we had larger quantities or whatnot, this would be kind of our go-to for maybe job quoting replacement work. Temperate zones, common question, are these going to run efficiently in the Northeast? Certainly, we have kind of a cutoff there where it'll run more efficient in the lower Northeast than upper, and it's all based on ambient air. So this time of year, when we have warmer basements, or if we've ducted it and we're pulling in 90-degree air from outside, certainly we're going to have a higher rate of transfer through the compressor. But in general, our compressor has an operating range, and it has a sensing capability to turn on or off if it's outside of that range. Our ambient air range is 45 degrees to 120. Outside of that, the compressor would shut off and either de-ice or wait for a higher temp and rely on the elements. We install these only indoors. We like to install them in basements for the simple reason that we have a higher relative humidity in basements because they're typically concrete or stone foundations, that these are also make a good dehumidifier. So when the heat pump's running, it's equivalent to about a 15 to 20 plant dehumidifier. It's going to pull the relative humidity out of the air while operating and dehumidify the basement. In terms of installation, where to install the unit, our general rule of thumb right now is about 700 to 720 cubic feet of space. So what we're doing is we're only rotating air. We're not creating a positive or negative air pressure situation unless we're ducting it to different remote locations, and I'll go over that a little bit. But we want, a general rule of thumb, a 10 by 9 by 8 unconditioned space. That's a big part of this. Is if we're putting this in a louvered door, in a closet upstairs in a conditioned space, meaning an area that we heat or air condition by a thermostat, we're going to air condition that spot. So when we're in heating season and you have this in a louvered door upstairs in a closet, we're going to push air conditioning out that it's somewhat counter affecting what we're using a utility to heat the home. So we like to put these in unconditioned space like a mechanical room or a basement. When we dehumidify, naturally we're pulling water out of the air. So we do have a condensate drain. We have a primary and secondary condensate. Basically the secondary is just an overflow. They now come pre-installed with a barb fitting in them so that we can attach clear vinyl and either drop that to a drain or to a condensate pump. We need to make sure that we understand that we're going to need to get rid of water. And sometimes that's a little easier with ones that we have sump pumps or whatnot. If not, you're going to have to buy a condensate pump. We connect on the side of the tank for a bunch of reasons. The primary reason being that we didn't want to, in this time of year, we're really prone to this, is you have colder water coming in, a warmer ambient temp, and the pipes will sweat. Or God forbid, we have a leak. And if we had top connects, that's where the compressor is, that's where all the voltage contactor relays and coils are. We don't want water dripping on that. It can lead to an issue in terms of function. So we side tap the tank. Our hot and cold, as you can see on this, are on the sides for that reason solely of we don't want water ever dripping on top of the high voltage area. The condensate ports, again, are on the side also, a little bit behind where the hot and cold outlets are. Something to remember is those hot and cold inlets, especially the hot, actually have what's called as a J-tube. So it's important that we don't over tighten or move the nipples that are pre-installed. There's black lines on the nipples that are for the inlet and outlet. We don't want those to spin because we'll be directionally changing where the water is coming in or out. So it's important that we make sure that those lines are aligned when we're installing. Something that I think we're going to see quite a bit more over the years, in terms of heat pumps evolving. We put a heat pump in our basement this time of year, and our ambient temp outside is 90 degrees. Really, we would want to look at the possibility of ducting and or diverting air. Certainly warmer air, we're going to get a higher transfer rate. That if we duct this and pull air in from outside and say dump the cold air into a basement or a conditioned area where we could use the air conditioning, that would be great. Right now we have upped our capability for ducting, meaning you would buy a duct kit from us. The duct kit is simply a start collar. You see the inlet and outlet arrows, where all we're doing is installing start collars which can accept ductwork, being 8-inch flex duct. Initially, when we came out with our units 10 years ago, we could duct them 10 feet equivalent length, meaning the overall length of in and out would be 10 feet. We've now upped that to 50 feet. So our standard 50, 66, or 80-gallon tanks, you buy a duct kit, you can duct those up to 50 feet, 25 feet on the inlet, 25 feet out, or any combination thereof. We also have duct boosters. which means we could put an inline booster that would communicate through our condensate wire, and it would actually turn on 5 seconds after the heat pump activates, and it would boost the air to be able to run up to 100 feet. So if we get in a situation that we're trying to put in the basement and duct a long ways, we're capable of doing that now. That would be an add-on product. Operation. So I like to talk about this because this is kind of a tall tale sign to whether or not the compressor is working correctly. Certainly sound and decibels will come into play, but these units are tested to run at 51 decibels from 3 feet away. A lot of people will say, well, how do I know what decibel rating it is? I have decibel meters. They're inexpensive. You can buy for $15 nowadays. Or, God bless our smartphones. Smartphone apps for decibel meters are actually very accurate on our smartphones. You can download them free to be able to perform a test of whether or not it's operating correctly. We have an end switch on our condensate safety circuit. It's basically a continuity loop that makes continuity on install. We'd snip that wire and wire it into the end switch of a condensate pump. What that means is if the condensate pump isn't activating, it'll break the loop and it will tell the heat pump not to turn on because we could have water spilling out onto the floor. It would turn the compressor off and run element mode, and it would show a code that the condensate is not creating the loop. Some common questions, whenever you're going to install a heat pump water heater, how are we getting it there? Predominantly, heat pumps are going to be put into a van or a truck, laid down on their side. That's okay to do that. What we've now done is we've actually put in a time delay into the heat pump. So we're basically assuming that you're going to ship the water heater on its side. What that'll do is it'll roll out the oil from the compressor. So we've put a time delay of 45 minutes into the compressor of when power is first brought to the compressor. There's a time delay for that compressor to turn on based on oil settling and temperatures of the water in the tank being above 59 degrees. If either are not satisfied, the compressor will just stay off until the elements bring the water up to temp, and or the time delay for power going to the water heater has lapsed, and the compressor will turn on. Does the condensate require treatment? That's another common question. We're just pulling raw water out of the air, so it's non-acidic, non-caustic. So the water coming out of the condensate can be put anywhere into a septic tank, sewer, or directly out into a dry well or outside the dwelling. Probably one of our biggest questions now is, location. Certainly we're trying to just look for that 10 by 9 by 8 room, but we have different louver setups that if we need excess air, we can put them into these smaller rooms, meaning cubic feet of, primarily we want 700 to 720, but if you had a smaller room that we need a little bit more ambient air on the intake side, we would put a louver at the top of the door. If we're even smaller cubic feet wise, we'd put 2 louvers in, or we would start looking at a duct kit and ducting it to the remote locations. Again, we talked about it. I'd like to underline the fact that we say flex duct. The reason being for flex duct is it's going to minimize the sound that will reverberate through the house. Flex duct will eliminate that. Plus, it's pre-insulated. So, cold air hitting warmer air, we won't condense and have water issues in the flex or in the ductwork itself. Sizing, okay. Sizing is a big thing for us for heat pumps. On statewaterheaters.com, at the bottom, there's a sizing guide tab. That sizing guide tab will walk you through either commercial or residential sizing. We would choose electric residential. It would ask us a series of questions: how many people, how many showers back to back we want to take, how long the duration of the showers will be, and we'll size that based on algorithms we've installed in the sizing app, and give you a recommendation heat pump water heater wise. If the nice thing about the sizing guide is if we're presenting, say, to a homeowner, the sizing guide will actually give you a printable report that we can either print or email. It looks professional. It's electronically sized. It's perfect that way. It's a good presentation to give to the end user, to give them the comfort that you've actually sized it correctly. Plus, you can also ask them the questions directly, so you're involving them now in the portion of sizing, that if there are ever an issue down the road, you say, well, we had sized it based on the questions we had asked. Maybe what has changed? Let's try to figure out if we have a sizing issue. So you're now incorporating the end user in the decision of how large of a water heater should we have. When I teach heat pump water heaters technically, I like to teach them kind of like they're a rechargeable battery. So the general rule of thumb with heat pump water heaters, whether it's residential or commercial, larger is better. We want to size the water heater appropriately, but if you were to be larger, all we're doing is storing energy at a high rate of efficiency in a tank. So the longer we run the compressor at the lower amperage rather than elements, the better. We'll go into that a little bit more. A lot of people like to try to change the settings on the heat pump. They'll change from electric mode to efficiency mode to heat pump mode. Efficiency mode, if we have a high level of ambient air temperature wise, you may be able to recover completely on efficiency mode. That's great if you can. The reality is hybrid mode, though, makes that decision for you based on algorithms that we've been federally mandated on. So there's guidelines to heat pump water heaters that we didn't just make up. We were actually given these federal mandates to abide by, and in the hybrid mode will make those decisions to switch back from element mode, both, or just electric mode if there's a failure. So again, I want to underline that we really want to keep it in hybrid mode primarily. Are there any questions out there yet, Mark, or anything? No.
I was actually going to just bring up a couple of things.
Yeah.
You had a couple of so what is being stocked in your distribution center to all members is the 50 and the 80 gallon, I believe 10-year hybrids. We see that probably 99% of them, if it's not a job, is a 10-year product. So that extra 4 years is a nice piece of security, and it makes sense that way. But anything additional that is not stocked in your distribution center, the Granite Group has 45 locations spread out around New England. So where we can, there could always be an order placed, and we can deliver it directly to you or into your distribution center, whatever is going to work best for you. But I just want to get that out there. You're stocking 50 and 80 hybrids and 50 gallon electrics. Anything else would be a special order, and it would basically take same day, next day for most instances, unless it's something very bizarre. And we are backed up by our distribution center in Londonderry, which is about 200,000 square feet as well, which stocks product. So wanted to bring up that. And then decibels, 51 decibels, Chris. What does that equal to in like an appliance? I used to tell people it's like a refrigerator. Is that an accurate thing to say?
It'd be a little bit louder than a refrigerator. It's more towards a newer, efficient window air conditioner. Okay. That would really be more, or it'd be a perfect similarity to a dehumidifier, to be honest with you.
Okay.
That's a perfect comparison. So it makes a little bit of noise. You certainly don't want it in your closet, in your bedroom per se. That's the general rule. Okay.
And as far as service, there's filters on it. There's service is minimal, but should the homeowner clean filters or anything? How does that work out?
I mean, it's going to be a matter of, the level of dust and particulates in the air. It's not a really fine mesh filter. What I'll see in the field is, when we've had a high level of construction or something happening there, yes, the filter could clog up. We certainly don't ever want to remove it per se, but the particles that filter will grab, you can just pull it out and it's a reusable, washable filter. That's important. If you ever notice, the unit has quite a few codes. So if the unit were ever to say ice, meaning that the coil has iced up, that could be that the filter has clogged, and that would be something we'd want to look at. But the unit's fairly smart in that way. It has what's called freeze protection. So if we're not moving enough air because of a clogged filter, it would kick the code, but it would actually still run by going just to elements and defrost the coil in the interim. In terms of warranty, like you said, 99% of this market is a 10-year market product. With regards to warranty, that's non-prorated, so that's a full replacement tank if it were to leak. We always get questions in regards to the compressor and what the installer and/or homeowners is going to be responsible for to replace or fix. In terms of the compressor itself and the refrigerant that is factory sealed, we will never ask you to do any kind of service or change anything there. If we happen to have a Schrader valve that was leaking or whatnot, we get a low pressure scenario, we would replace the entire unit. Some things, and this happens this time of year more so than any other, the other items are somewhat related to a condenser outside that we would have you replace. And certainly thunderstorms are prone to these issues. And again, related to condensers like air conditioning is we'll have you do some electrical changing on the unit. Things that blow out in the summer from thunderstorms and lightning strikes, contactor relays, coils and capacitors. So those are two items we will have you replace. The only other working, moving item is the fan motor and the fan bearing assembly that moves the air across the coil. If the bearing were to seize or the fan motor were to go, we'd have you replace that. Really, those three components, though, are quick, easy fixes. Other than that, the other things that we would have you change if they were to wear out would be the elements themselves, like a standard electric water heater. We have 4,500 watt elements. What is neat about our water heater, though, is the elements, if they were to not have continuity, or for that matter, to be ohming out incorrectly, the unit's board will sense that, and it'll tell you whether or not the upper or lower element have failed. So the diagnostics will actually tell you whether or not that's failed. You don't have to test it per se. Other than that, we do recommend you once a year flushing the tank. A good heavy flush is always good to do. We don't want you to do it just out of the hot and cold. We'd like you to do it where the sediment's going to settle off the boiler drain off the bottom of the unit, just to purge out any sediment that's settling at the bottom. That's it, though. Other than that, we're very easygoing, and with regards to our warranties, we just ask that the call be made into tech site on scene. We'll have you do some testing. The only other testing that we'll have you do in the field, other than some electronic testing, is we'll have you take the ambient air temperatures. The way for us to simply know if the compressor is working is whether or not we have colder outlet air coming out of the unit. So the only thing we'll really have you do to test if the compressor is working properly is what's our air going in, so what's the room temperature, say it's 70 degrees, we want at least a 10-degree differential coming out. So if the room were 70, we want to hear you say that it's going to be 58-degree air coming out of the outlet side of the heat pump. That's what is indicating whether or not to us, whether we're efficiently cooling or efficiently heating the hot water using the compressor. That's it. We won't have you break anything else down.
An additional question we have from Kara, and Kara, we will get to the difference between State and A.O. Smith and Granite Group. We wanted to get into the nuts and bolts first, where people are, are busy this time of year. So, but there's a question that Kara has that I wanted to, and that's going to coverage on share the coverage. How does the dealer get registered as a service agent? Because some of the dealers in their network do service. So is that an opportunity for all of us? I know it's funny that it's not, I know that state has not had people work on the compressors on the field. So how would that, if you could talk a little bit about that,
Yeah,
are there opportunities or?
Yep. So there's a couple things that, service agents are one thing. That would be a flight down at some point to actually take our residential course to be trained on our residential electric water heaters, heat pumps included. That would be getting you in the market to be a certified service rep. So wouldn't be the appliance company had necessarily sold the product. If they take that course and they're licensed, they would be called upon our service department to go out and service the units. Kind of a different segment that primarily, the plumbers and the mechanical contractors are a part of. If you're a licensed contractor though, and you want to do that, we are always looking for service agents. We can hone in on the products, that you want to specifically service. In this instance, it'd be electric only. There's another route that we can go to is we in terms of trainings, we have a certification program that we actually have solely electronic. It's a certification for installation that we have on our technical training tab on statewaterheaters.com. It's a self-taught video session with a quick test that would kind of just cover the basics of all things heat pumps. So really we have kind of our self-certified level or our service agent level. Service agents though, that's going to be a course that we want you to take down at the factory at some point because we want hands-on training on that. You ad lib to that at all, Jason? Or
No, I guess the only thing that I would add to it is, being, familiar with, the dealer network. There are some that have their own inside repair folks. So those folks would be eligible to become service agents to do repairs on their own products. I'd say reach to, your local Granite Group salesman who could get in contact with us, and we can formalize that process. But
Yep.
that is an option that is available to those dealers that do have their own service network.
Yep. Good. I'll keep going. So diving in a little bit deeper into the algorithms and the recoveries, again, all underlining sizing. Some common calls I'll get is, and this is the best call, is I'll get the call that the unit runs all day. And you'll want to qualify that. Is something wrong with it? So they'll say the heat pump water here runs all day, and they'll mean the compressor is running all day. And that's really what we want to hear. We want to hear that the heat pump is running anywhere from 6 to 8 hours after morning usage. It's when we get to the level of duress that the elements are going to kick in, and that's where we're not saving money. So what we really want to hone in on is running the heat pump for a longer duration, 6 to 8 hours, because we're running off of 2.2 amps. When we're putting duress, and that would be where we're drawing over 66% capacity of the tank. And again, this is federally mandated, so there's really no difference amongst brands per se. This is a design that Energy Star mandated us. Is once we get over 66% draw, that's where we show duress, and our board will kick the elements in. Our elements though are 18 amps, and we'll run congruently the compressor at 2.2, 2.3 amps. We're now not efficient. So what we want to hear is we want to hear that the heat pump's running long durations over the course of the day. If we don't hear that, it means we're pulling too large of a bulk draw, and we're turning the elements on, and that's where people don't save money. The elements specifically activate under one algorithm that's under high water usage, so we call it a bulk draw, and that's roughly when we get a differential of 27 degrees. So our set temperature is 120, 125. We get a bulk draw, an immediate draw, one usage draw, and we get a 27-degree drop in one shot. That's where we're going to turn the elements on. And typically that's going to hit 66% of the draw of the tank. We're federally mandated by what's called a first hour draw test. And that's, again, what's dictating whether or not the elements come on. First hour draw test is over the course of an hour, a 3 gallon per minute draw. Once it hits 66% gallons of used water, it'll automatically turn the elements on regardless of what the differential is. So we have two kind of sensing elements to turning the elements on, whether it's the 27 gallon draw in one hit or a slow long draw that's used 66% of the tank. So for example, useful water, bulk draw capacity without going into duress, a 50 gallon water heater, usable water before we're going to duress is 33 gallons, okay? So that's actual, people always say, well, I have a 50 gallon tank. In terms of electric water heaters, and it doesn't matter if it's heat pumps or standard electric water heaters, the rule of thumb between them and storage tanks, 70 to 75% of the water is usable at one time. So for a 50 gallon, usable water is 33 gallons for an initial draw. That's important because when we're sizing up someone's home, we're asking these questions of, do we take back-to-back showers? Because if you do, we have two people that take 10-minute showers. Our shower heads, hot water in the Northeast, 1.75 of that is hot water a minute. We can calculate a 10-minute shower is 17.5 gallons. You're going to get two back-to-back showers out of a 50-gallon heat pump before it's in full duress and doesn't have any more hot water and needs to recover. It's just pure math. So in hybrid mode, that's why it's important, because it's taking those calculations. Say we have an off day where we have company, we want that compressor and element to work together. That only happens in hybrid mode. In hybrid mode, if we get a combined draw, meaning both are running, that's when we're running at 21 amps and we're not saving money per se. So it's really important to try to size our usage, especially with back-to-back showers. That's really your highest bulk draw. Heat pump water heaters. So the best install of a heat pump water heater is to pin it to its highest setting. Some of ours are now 140. Predominantly, most of ours are 145, especially the 10-year series is 145. So you want, in the best scenario, to set the heat pump at 145 degrees and install a mixing valve. We're going to store our energy over a long duration using only the compressor, and we're storing that energy for future use. And then we mix it down so that we can't scald. Another thing that's a common issue is the unit has to be perfectly level. If we're not level, we're going to settle the oil into a certain part of the compressor. We're going to be prone to condensation coming through the lines and or overheating the compressor and seizing it. So level's very important. Breakers, I'm a broken record on that, but we want to put eyes on that we see a 30 amp double pole breaker. You also want to make sure your gauge of wire is correct. We're pulling all of 80% draw on the 30 amp pole breaker. That if we're something 12 or 14 gauge wire, it's going to heat up and you're not going to get as much of a draw capacity that we're not going to recover at a rate that we'd like to. Will it trip the unit? No. If we had a 20 amp breaker, I've seen it before, the unit will run, but I'm going to get a pretty immediate complaint that I don't have enough hot water. You just want to double check that what someone else did when we're replacing it is correct. The other thing is, and I get it commonly this time of year too, but more so in the winter, is the location of where the outlet air is going. So the cold air that we've dehumidified, if it's bouncing off a close proximity wall or is closely placed to the outside of the basement wall, we'll get a counter rotation where we're spinning the cold air back into the inlet, and we're not going to make hot water efficiently using the compressor. So it's important that we try to directionally position the heat pump so that we're getting a counter rotation of the air throughout that 10 by 9 by 8 room. I wanted to hit a little bit on rebates in the Northeast. The reason being is that's really what's driving this market. I mean, a lot of our states, we're seeing 50-gallon heat pumps after rebates go out for $300, which is less than a standard electric water heater at this point. Every state has their own programs, usually multiple programs if we have multiple utilities. I highlighted really what's, the latest and greatest for 2020. Just in terms of Vermont right now, Efficiency Vermont is the catalyst, and they have 2 levels of rebates. They have a tier 1 and tier 2. So that basically what that is 6-year product, which we're not really selling in Vermont, but tier 1, tier 2, 6-year product for the 50, 66, or 80 has a $300 rebate. What we're going to see primarily in Vermont is 10-year product. So that's a $600 rebate on all gallon sizes. So like Mark said, you guys primarily stock the 50 and 80. Those would have $600 rebates in Vermont. New Hampshire saves a little bit different. They have multiple utility companies in place in New Hampshire. The larger utility is Electric Co-op, New Hampshire's Electric Co-op. All they do is mandate a UEF of 2.3 or higher. As you know from what I told you earlier, our threshold is really around 3.4. 10-year products all at 3.45. So all of our gallon sizes would qualify for $750 rebate with Electric Co-op. The other companies, Eversource, Liberty, and Unitel, again, threshold of 2.3 UEF. You're going to get a $500 rebate on 50 gallons. In new, within the last couple of weeks, a $600 rebate on 80 gallons. With heat pump rebates, really until the last year, we haven't had any rebates for 80-gallon heat pump water heaters because of how we're now rating them with Energy Star. The UEF algorithm didn't take into play the design mind frame of heat pump water heaters of bigger is better. In general, the market has changed from bulk storage it being bad. So, all things low water mass were really what were being rebated. We're now changing that by being more informed. The thing with New Hampshire is you have to qualify that the funds are available and that it's by rebate form. So you can do it online or you can send in a form, but those are not guaranteed funds. Vermont, really, I haven't had a year that they've run out of the funds. Still, I would recommend qualifying whether or not you're going to get that rebate, but New Hampshire primarily is prone to running out of funds prematurely. Efficiency Maine, they have a flat rebate on 50-gallon heat pump water heaters of $750, and the cell up there is $249 for a 50-gallon heat pump. That's what they publish on Efficiency Maine. Mass Save, again, a little bit different than Maine, though. I need to correct myself. Maine is what we call as an upstream rebate. They're like Connecticut. So that's an instant rebate. You're leaving the Granite Group with a $249 water heater, and Granite Group is being reimbursed, unlike Vermont, New Hampshire, Massachusetts, Rhode Island, where you're sending a form in. Mass Save is the same. You're going to send in a form or you're going to fill out an online form. They have now 2 forms of rebates. They've now added above 55 gallon. There is a $150 rebate. It was 0 last year, so it's nice to see that. 55 gallon or less, so 50 gallon heat pumps, there's a $600 rebate. Again, it's a form fill. Rhode Island is controlled, their electric grid is National Grid, so parent company from New York. They have a program that's through National Grid. It's form filled also, so it's not an instant rebate of anything 55 or less with a UEF of 2.0 or higher is $600. So 50-gallon heat pumps are $600. It'll be a credit on your electric bill. You can ask for cash rebate though, but it's primarily a credit onto that electric account. Electric heat pumps 55 and greater in Rhode Island have a $150 credit, and or you can request a cash rebate, but that would be to the end user only. CT Energize, they have an upstream program, meaning it's an instant rebate through Granite Group. That would be a point of sale rebate of $750 for a 50-gallon heat pump. And for a limited time through November 30th, we have worked with Eversource to supplement that for an additional $100. So this is a unique program to state. I don't want to say that other manufacturers are not trailing that, additional rebate, but as of now, we're the only ones with the additional $100 rebate. So it's an $850 rebate on 50-gallon heat pumps. Nice to see also is 55 and greater, so 66 and 80s in Connecticut would also have an instant rebate of $400 now, which we're trying to hedge the market towards those rebates on the larger tanks too. But that's a general overview of me trying to break down 100 pages worth of rebates from different websites, those 2 pages there.
Chris, a quick question. So the group, the New England group, is bringing these into their distribution center, going out to the branches. How does this affect the rebates that are sold at any one of these states, the upstream ones? How is that? Is there a logistic way to that to happen?
So the upstream rebate, I'd have to understand a little bit more. Are you consigning or you're stocking? Are you consigning with?
They're being purchased by the New England group, so
yeah.
we'd have to work with the individual dealers and get them connected with the utility so that we can get them enrolled in the program.
Yes.
So, so the instant rebate from the Granite, unless it's being shipped directly from the Granite Group to the location, they would get the instant rebate. But because the dealer's pulling that product from the distribution center of the New England Group, it works differently. So we would just have to get them connected with the utility and put that piece together.
Yes.
More likely that would be more of a downstream program where the consumer got the rebate directly from the utility.
Right.
Correct.
That's what I kind of figured. And just as an add-on, I think just this week, the 80 gallons were added to Efficiency Main. Am I correct with that, Jason?
Yes.
Yes. Yep.
Okay.
$100, $150, right? I think it's $150.
Yeah.
That's the review there. That's primarily it for me, unless we wanted to get into, some other individual questions. Certainly, the one thing that I'd like to underline is technically, we really don't have, people tend to look at heat pump water heaters as if they're really high tech per se. It's a glorified window air conditioner on top of a tank, truly. We're not asking you to break it down and to fix it, other than things that can happen lightning strike wise. It's a plug and play in a full non-prorated replacement, unlike our competitors. So, with between us and Granite Group, we'll help you through any issues you have.
Okay, cool. Very well done. Thank you. I don't see any additional questions, but I do want to get back to a couple of things that, so who are we? Who are you? When Chris is done with this call, he may be putting on an A.O. Smith shirt. Reason for that, we are the Granite Group. First, I want to thank Coburn, who does a lot of this backroom stuff for the Granite Group and puts these things together so we can do it. And we just enter a code and look at that. Here we are. So Coburn Flannery is responsible for that. I want to thank him. But so Granite, I'll tell you a little bit, let's talk a little bit about Granite Group. Granite Group is a 45-branch wholesaler covering the New England market. Back in October, we reached an agreement with, and Granite Group stocks state water heaters. Back in October, we reached an agreement where Granite Group purchased Weber Supply. Weber, it was heating and a heating house, but really specialty on the water heaters. So that's where your relationship came. They actually stocked A.O. Smith. So what's the difference between both products? The color. I'll let Jason jump into this, but it's a brand, State and A.O. Smith, just different brands of the same company. Warranties are the same, but I'm going to shut up and say, Jason, bail me out.
I don't know if there's a whole lot more to add to that. State water heaters and A.O. Smith water heaters are different brands of A.O. Smith water products. So it ended up being a function of who's supplying that product to the New England group. Granite Group is a state water heater distributor. So that's really what it boils down to, and much of the same in terms of the product. If you had a previous A.O. Smith product that was in the marketplace that you sold in previous years, and you had a warranty issue with that, we'd work with you through that issue. And so from a warranty standpoint, there wouldn't be any concerns as well. So, and I think we've dealt with one or two in the past year or 6 months or so that we were able to help people through. So same product, same warranty, same great service. So.
And the same rep. These gentlemen are with Urel, and they represent, the entire gambit of A.O. Smith water heaters. So it all comes to just change their shirts for the next, as I said, next call. But same support, all done the same. Just want to get everyone comfortable exactly what's, how this all kind of interplays.
Sounds good.
Any other questions out there?
Doesn't appear that way.
All right.
Okay. Appreciate it. This is on, as I said, this is recorded, so we're not opposed as a group. If something else transpires and you'd like more training this way, we definitely are all on board to do it. So something we can discuss in the future. But I want to thank everyone, and
thank you to Kara for putting this together.
Appreciate it.
Thank you so much.
All righty. Have a great day.
Take care.
Bye.